Okay, welcome back. Our next session will explore the cross-cutting roles of technology, innovation and growth in tackling global grand challenges. In it, we'll consider how we can ensure that the best research results in innovative products and services, and how the state can support innovation without crowding out the entrepreneurial spirit. We'll consider whether the pursuit of economic growth is compatible with the goal of tackling the global grand challenges. Technology and growth is a theme which, like education, cuts across the other topics of this summit. So the format for this session will be similar to the one for the education session yesterday, in that we'll hear from the keynote speaker, followed by very brief introductions from all the other panelists, and then we'll launch straight into a lengthier discussion. So I'd like to introduce the panelists for the session. Our keynote speaker at the far end is Dr. Mike Lynch, founder of Invoke Capital. Dr. Margaret Ann Craig is CEO of Clyde Biosciences. Dr. Regina Dugan is Senior Vice President of Advanced Technology and Projects at Motorola Mobility. Andrew Sims is Fellow of the New Economics Foundation. And Professor Andy Hopper is President of the IET and Head of Computer Laboratories at the University of Cambridge. And Dr. Yingtao Li is President of the 2012 Laboratories at Huawei Technology Company Limited. So I'd like to invite Mike Lynch to deliver the keynote speech.
Good morning, everyone. On the subject of the importance of innovation, obviously many of us in the room are familiar with some of the grand challenges that humanity faces at the moment, and we could spend an hour listing them, whether that be security of energy supply or microbial resistance to antibiotics, or the issues around security in a world where technology is getting even more advanced. That's even before we come on to the opportunities to move forward, things like the amazing work that's going on around genomics and the analysis of information, and some of the new goals, for example, in understanding how the brain functions and how we can use that. Now, all of these things are predicated on research and innovation, but in order to actually change the world, they also have to have impacts. They have to actually get out there and make a change. Now, before we start, I should say, for those of you that have noticed how much newsprint I'm using up at the moment, I do actually believe absolutely fundamentally in innovation in all things except accounting. So, as I said at the Royal Society, that's the one area where one shouldn't have it. Now, let's talk a little bit about innovation. Now, the big danger here is that this is a bit like discussing the animal kingdom. And if you're a tiger and you get up on stage, you start talking about what it's like to be a tiger, and the dung beetle at the end of the panel completely disagrees with you because, of course, it's fundamentally different. So the first thing is beware generalizations, and I think one of the great things about today's session is that we have panelists that cover a large spectrum of the different routes to innovation. Now, innovation is something that is a word that people love to use. Politicians love it. Company marketing departments love it. It's actually a very interesting word. If you look back at its original roots, when it was first used in the English language, it was a bad thing. Basically, the word innovation was used to denote something which was a change and therefore highly suspect and bad. Obviously, we've gone to the other extreme now, where one can actually sometimes fear that there's almost an innovation industry. So, I'm someone who's sat there and just done this ad hoc over the years in multiple companies, and I see these sort of business books about innovation and consultants and all this sort of stuff. And I have to say, when I read it, it bears very little relation to at least my experience of life. So what I'd like to do really is try and look at some of these ideas and see what they are. Now, I have to admit up front, when it comes to innovation, I'm a believer in the sort of efficient market hypothesis. So in the financial world, the idea there is as soon as you can sort of publish an algorithm that's going to make money, then of course everyone uses it and the utility of that goes out of the market and you can't make money anymore. And I think innovation is a little bit like that. If it was easy enough that you could read a book or get a pack, then obviously everyone's doing it, and it no longer gets called innovation. In fact, we might argue that, for example, some bits of project management are examples of innovative methods which have become mainstream and therefore not innovative. But what I think you can do is talk about the necessary environment, rather than like getting a seed to germinate. What do you need to put around in order to create innovation? Obviously, the magic of the seed may be something you can't recreate, but of course you can create the place around it. Now, lots of people talk about lots of things. There's some very interesting case studies. There's very interesting academic work. Bill Janeway's recent book about the effect of the perhaps irrational over-exuberance of venture capital in the US and its effect on the rate of innovation, which was very positive for innovators and very negative for investors in the end. Or indeed case studies such as government-related aspects such as DARPA, where we've seen amazing things come out over the years. The problem with that generalization, of course, is there are counter cases. So if you think about the European Union's attempt to create a European Google called Quero, where large amounts of money were made available in order to produce the European Google. And not only did it fail, but it actually had a scorched earth policy, in that no one would invest in related areas in Europe from the private sector, thus killing off a lot of innovation. You can contrast that, which is not a capital-intensive area, with things where capital really gives you power, like aerospace, where, for example, we have Boeing and we have Airbus, both of whom would say, of course, they're completely independent of the respective governments, but the reality is that the systems are set up to use the power of capital to give them advantage in what they're doing. The other thing that's very difficult to talk about in how one deals with this problem is the global differences. The situation in the US is very different to the situation in the UK, which in turn is very different, for example, to continental Europe, which in turn is different to what's going on in Asia. Now, obviously, my experience is more out of the UK and the US, so that's what I'm going to talk to. And I think we may have some very interesting perspectives from some other parts of the world. The first problem that we have in the UK is one of culture. We do still have this concept of the purity of academic research. It's changing rapidly. I was an academic doing research, and in my day, technology transfer was seen as something slightly suspect. That has changed, but we still have, in the UK, a very different cultural approach. In the US, there tends to be a can-do model. This very institution, it was then the IEE, about 20 years ago produced an article, and it was 10 ways to shoot down any good idea. And it's wonderful. You can use it to kill anything. It's got the perfect answer and everything. But the important point is that it's always easy to find a way of killing off something. And if you have a cultural approach which tends to be a little bit cynical, that can be difficult to get things going. We also have a very interesting debate about the role of the individual. On the panel, you're going to have people from organizations where the only way forward is massive collaboration. You're going to have other situations where an individual makes an amazing difference. Would we have Apple products the way they are if Steve Jobs had never existed? And I think from the people that I know that worked with him, he brought something very special to that, and that was about being an individual and perhaps not doing things in an orthodox way. Whereas if you're going to produce the latest aero engine, there can be amazing creativity in that, but it very much is something where it's a part of a team in doing that. In the UK, our universities are right up there. Our top science universities produce amazing research and graduates, but we've had great difficulty in getting that technology transferred out into economic impact. There's a lot of work that needs to go on here. Things like, how does the IP system work? Does the university own the IP? Does the person who did the research own the IP? How much goes between them? Can universities own shares in companies? These models that have worked very well, for example, for institutions like Stanford, we need to start thinking about those in the UK. Now, the good news is it's changing. The importance of, where applicable, research at universities having an economic impact is starting to be well understood. It's well understood by government here, and it's well understood, I think, by the universities, although it is early days. They're still feeling their way in doing that. We have a series of other issues. So, for example, finance. Now, one of the things that annoys me intensely in the UK is it's so easy when you get a group of entrepreneurs and they all sit in a room, they blame the venture capitalists. And they're a very easy bunch to blame. They don't do themselves any favours sometimes in how they present themselves. But they are rational beings, and the decisions that they make are rational. So, for example, in the UK, we have a problem where we don't really capitalise on a lot of our great young companies because, as the entrepreneurs will put it, the VCs sell out too early, and rather a company that could become $1 billion company is sold at a valuation of 100 million, and often the IP moves out of the UK. Well, there are reasons for that. It's not just VCs not thinking the right way. They're making perfectly rational decisions, and the reasons for that are to do with how the equity capital markets work in the UK. So what we have to is go through and deal with these things. And the most important thing about seeing the impact of innovation is to realise it's a pipeline. We can start with someone perhaps at a university in a bench, and they have a great idea, and then it has to go through a whole series of stages to get to a world-class company or product that takes massive market share, whichever route. And it only takes a few of those stages to be blocked, and you can't get through the pipeline. And so those are the sort of things we look at. Early stage finance is a real issue in the UK. It's actually a real issue in the US in that there is no scalable industry for early stage finance. Because of the cultural differences, your uncle is more likely to give you that $15,000 to get started than your aunt is in the UK. She's more likely to keep it in the building society nice and safe. And what that means is where you have a structural issue there, it's getting bridged in the US, but not so much in the UK. Obviously, government has to play its role. It has to, first of all, appreciate the importance of innovation and growth. I think in the UK that's happening now. John Rose, who was the chairman of Rolls-Royce, had a very simple saying, which was, if you look at the UK situation, how do you make prosperity? You grow it, you dig it out of the ground, or you use creativity and know-how to turn something into something more valuable. Well, in the UK, we're actually very, very good at growing it. We do it incredibly efficiently. Sadly, the UK is not sitting on vast gold reserves, so we're not really going to get too far on that one. So it's all down to the last one, and I think that's a message that government's got. Now government has the challenge of working out what to do. You know, we've had the situation where you can't pick winners. That obviously doesn't work. We have the Quero example where you can actually go backwards by doing the wrong thing. How do you actually encourage entrepreneurs? And I think we're going to hear some of that from some of the panel there. So, very, very interesting question, vital for how we move forward. There are some important things to understand about the current environment, though. When I was doing research work and trying to make prototypes, if I wanted to use a new chip, I had to send a letter off to the chip manufacturer, and about 3 weeks later back came the data sheet, and I could decide whether to use the chip, and I'd go and order the chip. That all happens in seconds on the internet now. If I want to go online and find someone who's used that chip before, I can just get put in touch with them even if they're on the other side of the world. So the ability to utilize knowledge is growing at an exponential rate. The value of our knowledge, I believe, is growing because of its impactfulness. And then what we have is a situation where we look at the enabling technologies, things like connectivity, the ability of, we're all carrying supercomputers in our pockets now, smartphones. They can see and they can hear. We have suddenly the ability to do mass genetic sequencing. We can go on and on. We're in a period of phenomenal change where tools are allowing us to do things more complex and more rapidly. And we're about to enter some fundamental new areas. You know, genetics and its analysis driving personal medicine, or the ability of computers to actually understand what stuff means, what they're looking at, what they're hearing, are going to change the world around us. So what I've been doing is looking at the UK and saying there's this great resource of fundamental technology. How do I actually get that unlocked to have the commercial impact it should? And I've been working with Invoke, and what Invoke is rather different in that we have lots of the managers that have grown up through companies like Autonomy and other successful companies in the UK, and they're part of it. So what we can do is go into a small company and actually bring the expertise about how you productize it and market it, and all those things that aren't about the technology, but are about making the technology useful, and actually get it out. Now, that's a big problem in the UK, because there isn't that talent around, whereas in Silicon Valley, you can have a Rolodex of that. So we think that we can bridge that gap. We're also have scientists, so we can go in very early before a venture capitalist traditionally could evaluate something, even when it's in pieces on a bench, and we think that allows possibly a solution to the very early stage funding. And then at the other end of the spectrum, we have the people that can do large corporate transactions. So rather than sell that business when it's at 100 million, we can actually go and buy a large legacy player for a couple of billion and then use the technology in that. So these are examples of addressing the issue in a different way, rather than the traditional models of private equity and venture capital in terms of funding, rather than the traditional models where you're limited by the management expertise that you have around in the technology transfer field. And it's going to be great fun to do that and learn and see if that deals with the UK's problem. It's a specific thing for the UK. So in conclusion, I think the question of innovation is vital for humankind. We have now a series of fundamental problems. And although this may well be considered in some quarters a very controversial statement, most of those problems are probably going to come down to innovation, research, and creativity for ways of us to solve them. And with that, you can now see the importance of listening to the rest of the panel. Thank you very much.
Thank you very much, Mike. Well, I'm now going to ask the rest of the panelists to give very brief 1-minute introductions, I guess starting from you, Margaret and Craig.
Good morning, everyone. It's wonderful to be here. So to me, this is quite a pertinent, a relevant argument, and that I am CEO of a university spin-out company. And universities are full of technology, outstanding technology, but the implementation of this technology in the commercialisation process is often very difficult. Universities can be quite ill-equipped to deal with the commercialisation process. We, as academics, face issues such as equity, time, resource, and incentive to actually develop our technology and commercialise it. Clyde Biosciences is an example of outstanding technology. We're a multidisciplinary team of scientists and engineers that are tackling a real medical need. We produce technologies that are aimed at healthcare and the drug discovery market, where we see our technology saving millions of pounds, accelerating the drug discovery process, and bringing more drugs out and allowing more drugs to be more accessible. It's a really relevant argument today, especially when we're facing the global challenge of, and in the press this week, the Chief Medical Officer did say that Britain's health system could slip back by 200 years if we do not face the threat of antibiotic resistance. So this threat ranks alongside threats such as climate change and global warming. So we, as a university spin-out company, have the ability and the technology to make an impact and accelerate this process and bring new drugs to market. But what we face is the commercialisation process is difficult, and what we need to do is be better at that and gain more support and support from government to get technologies out there and make a difference.
Thank you. Next, Andrew Sims.
Equally glad to be here in the company of engineers who I'm glad to say I enjoy the company of far more than economists. I like engineers because they make things, and also because if they make things that then fall down, the chances are that you'll probably end up in court. If you're an economist and you make something and it breaks, the chances are you'll get a bonus and some nice little advisory role somewhere. The reason I like engineers is that you understand limits, you understand tolerance levels, stresses, strains, compressions. You know how to work with the real world. This is something that contemporary economics has fabulously failed at delivering. And many of the underlying assumptions of the economic model that we work with at the moment. And I'll distinguish here between desirable kinds of growth in terms of how cultures grow, how we grow in maturity and insight and understanding, and the growth in orthodox GDP, GNP, which is a very specific thing, and it's important to disaggregate because from the earliest days of economics, from Adam Smith and Ricardo and John Stuart Mill, they've understood that growth is a phase that economies go through until they get to the point where their basic needs are met. Most advanced industrialized economies today are decades past the point where further conventional economic growth contributes any more to our well-being and life satisfaction. So the innovation that we've heard about now is how can we learn to flourish and prosper within the tolerance levels of the biosphere, many of which we have already transgressed. Now, engineering has an enormous part to play in that. But if we think we can simply engineer our way within business as usual and keep growing as we have been, I believe that's wrong. The best science available at the moment is telling us that that's not the case, that within already advanced countries, and it's different for still developing countries like the OECD, that further conventional growth is not compatible with keeping global temperature rises at a 2, 3, or even 4 degree rise. And a 2 degree rise takes us beyond the point that the environmental dominoes kick in. At the same time, we've noticed that the returns to the people at the bottom of the global income pile from conventional models have been getting worse. So we need innovation, but we need social and economic innovation as much as anything else. For example, rather than the quantitative easing we've seen, which has just been like a carousel of paper and money between the banks and the Bank of England, I don't see why we can't use the new Green Investment Bank to inject money directly into the economy to start investing in the new infrastructure of a low-carbon transition for the UK. We can look at innovations in our working week, like a 4-day week, which in Utah introduced at the height of the crisis in 2008, enabled the local authorities to save millions of dollars, reduce their carbon emissions by 14%, increase staff morale, and lower absentee rates. So my call to you, as we start thinking in terms of how we can arrive at an economy which is in dynamic equilibrium, a term from forest ecology, rather than assuming we can have infinite growth in a finite space, that's what we need. We need, yes, engineering innovation, but we need economic, social, and indeed some political innovation to help us live within a dynamic equilibrium of the planet upon which we depend. I'll pause there.
Thank you, Andrew. Thanks so much. Regina Dugan.
Good morning. Innovation is a discipline. Now, many believe this is a contradiction. They view innovation as unpredictable, ethereal, like magic pixie dust. As a result, it's commonly approached as a necessary but elusive investment in the future. I argue instead that innovation can be understood, practiced, and organized for success. I've seen it and lived it. So recently, I had the great privilege of being the director of DARPA, the Defense Advanced Research Projects Agency. For those of you who don't know it, DARPA was formed in 1958 after the launch of Sputnik. It has a singular mission, the creation and prevention of strategic surprise. It's a $3 billion a year organization, and it is run by some of the best scientists and engineers in the United States. They work on high-stakes problems, life and death problems, and at the absolute edges of advances in science and engineering. The result, for over half a century, DARPA has been at the epicenter of some of the most important breakthroughs in the world. Not incremental breakthroughs, but world-changing breakthroughs. From stealth to the internet, to GPS, MEMS, modern material science, the list is very long. And if you don't know DARPA, I can assure you that your life knows DARPA. So how is it that this little 200-person organization has managed such a long-standing track record of innovation? It was important to us while we were there to try and understand that. What we discovered, I think has implications for how research and development, how innovation is done across organizations. We found that the historical linear model of innovation, which argues that we start with basic science, move to applied science and engineering, and eventually productization and commercialization, is in fact not how it works. That model was developed in the 40s under significant policy pressures, a desire to collect statistics about where the dollars were being spent post-war, and to turn those dollars to economic benefit. There were now decades of statistical data gathering, and that linear model of innovation became social fact. And once that social fact is formed, it's very difficult to change it. Now, in 1997, Stokes wrote a different model of innovation. What he argued is that great breakthroughs in innovation happen actually at the intersection of advancing science and engineering and a driving application. And he called this intersection Pastor's Quadrant. And what we learned at DARPA was that precisely that intersection, that vibrant, driving intersection, is where the agency has been operating for over 50 years. We just didn't have a name for it. And that intersection, somewhat counterintuitively, produces results over and again. The risks are higher, not because risk has any inherent benefit, but because things of value inherently have risk. And it is hard work. Deep analytics are required to identify that intersection and hold to it. It demands and attracts great talent. And the project, the work itself, the drive for that outcome, causes us to cross disciplinary boundaries, stages of development, organizations, countries, and even personalities. Innovation, big, inspired innovation, is the result. The work is exhilarating. It is definitely not boring. And boring is the enemy of innovation. We believe that it is inherent to us to have work that has meaning, to create, to discover. And making is part of innovating. That driving application, the desire to make in the face of that, that is part of who we are, and it is intimately connected to innovation. And global grand challenges should feel that way. They should feel exhilarating, they should feel a little scary, and they should feel worthy of our time here. Thank you.
Thank you very much.
Thank you. Andy Hopper.
Well, first of all, if you permit me, just as president of the IET, on behalf of myself and the 150,000 members of the institution, it is the warmest welcome, and I hope you're getting intellectually stimulated, and also you're meeting new friends, and think well of the institution, which, as Mike says, used to be called the IEE until we broadened the scope and it became the IET. I'm a computer person, so I see the world through those eyes. And it has been said that over the last 5 years, nothing much has changed. Well, one thing that has changed, in particular in the developing world, is the spread of digital systems of all kinds, computers, communications, and so on. And so I think computing has a very important role, which tends to be underplayed, and is underplayed in the meeting here, in a role in sustainability. It spreads like wildfire, and I think might be a clue to how we might have our cake and eat it. When I say have our cake and eat it, the innovation that will allow society, people in the developing world in particular to have a higher standard of living without the footprint that we have. So that's what I'd like to understand is there a solution to that hard problem? Can we have our cake and eat it? And the premise is to have that sustainable growth, that the innovation in computing will absolutely change the way we lead our lives, which will be at the heart, actually, of the solution, in my humble opinion. That people will be content with that. So there was a talk of a happiness index yesterday. So in their own terms, whatever they are. And furthermore, I'm encouraged that much of the population of the developing world is young. And of course, they're the easiest to adopt, to take on these new things. And so from that point of view, I'm rather optimistic. And the kind of things I am said are a clue about what the incentives and the rewards on this platform, I think, will be. Don't know which ones, but something along those lines. So just a couple of tiny little thoughts about this intersection of computing and sustainability. So first of all, green computing is important, don't use too much energy. But the other way around, computing for green. Once you have low energy computing, you can observe the world, Google Earth on steroids, observe everything, optimize in a digital world where the footprint is slower, and then feed that back. And whether in manufacturing, which is where it's starting to happen now, transportation or agriculture, I think there are solutions in that to this conundrum. Can we have our cake and eat it? Another aspect of computing that's necessary once you go down this path is that it has to be assured in the sense of it always works, all data is always traceable, all decisions are always traceable, because if you base societal well-being on it, those sort of properties are necessary, and I think there's innovation there. And the assumption is obvious. Everybody on the planet will have a mobile phone. That's their slice of the cyber cake in their own hands. So that's a little taster. Now, innovation, how? And my main point is there is an important discussion about where and what the market should be. Okay? Where and what the market should be, so as to, on the one hand, let the stuff spread, but on the other hand, to have the flywheel of enterprise, wealth creation, and so on work properly. And there are three areas one might think about. One is regulation, how to deal with this, where the market and what should be. So, for example, regulation about carbon footprint. And here is where the academies, the three academies coming together, might have a role which is kind of influential and complementary to Kyoto, whatever. Two is standards. I've done communications. In communications, competing companies agree on standards, and then off they go, and it works. Well, why not agree standards with this sustainability aim? For example, if you're going to have some energy tariff, it's done in a standardized way, so that then people can play into it. So that standardization helps make a market in a different way, and standardization, with this in mind, I think is very important. And then finally, the third one is this university industry boundary. What should the charter for a university be? A little bit of what Mike was saying. I think there is quite a serious problem at the moment, because universities are in a position where at the margin they're essentially underfunded, and so they can make more money by selling the IP at a high price. And I think IP on this shelf is IP no good, and I think a strategy for volume is hugely important. So in summary, the innovation action I would perhaps commend for this conference is to address this we versus me, as was said earlier, boundary, and decide what's appropriate. Look at what barriers that exist to innovation can be reduced, so that we maximize the chance of this having your cake and eating it, that is letting society grow, but do it on an economic model that actually works.
Thank you very much.
And our final panelist is Dr. Yingtao Li.
It's a pleasure to attend this meeting. So according to the United Nations data, the global arable land is about 1.8 billion hectares. And according to the population, year 2011, 70 billion person, and almost everyone shared 2,500 square meters. At year 2050, 90 million, everyone will share about 2,000 square meters land. So the challenge for us engineers is how to do more things with less resource, because the resource is limited, natural resource. Last month, I attended the 2013, the annual Mobile World Conference in Barcelona, Spain. Every year, there are a lot of visitors, and last year it reached to 60,000 persons. This year, reached to 70,000 persons. People pay more attention to this Congress, not only because the mobile industry is the most active sector in the ICT, but also because that Congress is expanding its influence to other industry. ICT already helped other industry to improve the productivity, efficiency. It's a catalyst, enabler. It's also a general purpose technology. And ICT have contributed to education, healthcare, transportation, definitely communication itself. In ICT industry, the innovation should be based on customer requirements, obvious requirements, and potential requirements. For the obvious requirements, the task is easy, just to fulfill the customer requirement by innovative solution. But for the potential requirements, it's a little different. The customer sometimes, they don't know what they need, what they want. So for the innovator, we have to create new products and solutions to demonstrate to them, to show the customer, to stimulate and guide the customer potential requirements. So there are two kinds of innovations: demand-based innovation and vision-based innovation. No matter which innovation it is, the user will finally select the meaningful innovation for their practical application. Thank you.
Thank you very much.
Okay, so we can have the house lights up a bit. We have about 45 minutes for discussions, so can I have some questions, please? Good, so we have someone here at the front in the blue shirt, and a gentleman, just there with his hand still up, just, yep, there. Thank you.
Hello, my name is Yannis Eftichiou. I'm from the University of Bath. I feel it's a recurring theme talking about innovation and how funding innovation is risky. And I'm going to target this towards Regina, but it's pretty much open to everyone. But you say high-value innovation is inherently risky, which would appear as common sense. But could you please comment on who should take that risk? Is it, in the case of DARPA, it's easy to innovate with $3 billion every year from the US government. Who should fund innovation in the university? Is it the government? Is it the VCs? Is it the engineering designers themselves in the universities? Thank you.
Good question.
Yeah. So while at DARPA, we often got questions not unlike that. You know, how is it that the agency is in the position of picking winners and losers? And how is it, for example, competing with other forces, venture capitalism and so on? And the reason that DARPA exists is to fund high-risk work that wouldn't be funded otherwise. Our work is national security. DARPA is actually a tiny percentage of the overall U.S. Defense Department budget. It's a single-digit percentage. And yet it yields results over and again. And I think some of this is because the work which is project-focused at the intersection of big science and engineering and this driving urgent application. And that application, by the way, has to be real. It has to be authentic to focus the mind and inspire greater genius, right? It can't be created in the abstract. And that intersection has much higher risk, or so people think. And the really interesting, somewhat counterintuitive part of it is that despite that, it yields results far more reliably than lesser risks. So in order for that intersection to exist, you still have to have other healthy parts of the ecosystem. You still need a basic research organization. You still need the work of organizations like the National Science Foundation and strong research happening in other places. And you need a healthy economy to take the work that takes that kind of breakthrough innovation and makes it commercially successful. They all have to exist. But the piece that's often missing is that work at the intersection. That's the vital piece.
Thank you. Does anyone want to add anything to that?
I mean, maybe just one point. I mean, just take one area in particular which talks to the heart of one of the greatest challenges we have at the moment, and that's about shifting energy systems. And, you know, we're faced with a challenge, if we believe the science, of having a handful of years in which to radically re-gear, re-engineer our energy systems towards low-carbon sources. And if you look back through history, the investment and the money in new infrastructure that it's taken to shift from one energy system to another has always had substantial public funding as part of it. And at the moment, we're living through a moment of what I suppose you might describe as market failure, in which, as awareness of climate change goes up, actually the amount of money flowing through the City of London into the last generation's energy technologies, oil, coal and gas, is radically increasing. And we have a government who, through its tax breaks, has led to one of the fastest round of selling licenses in North Sea oil and gas that we've seen for years. So there you've got sort of multiple market failure, if you like. And if you're going to turn that round, and you look for examples in the last few years about where things have been changed, shifted in short periods of time, whether it's Denmark or whether it's in some places in Latin America at the moment, where they've made quick moves, or Germany even, then it's required government innovation and government support and government spending. And don't forget, as we talk a lot about innovation, let's not forget that many of the solutions to our problems are already at our feet. And the challenge is not necessarily more innovation, it's political will, mobilization and constituency building to get the damn things in place and rolled out at scale.
Thank you. Yes, next question there.
Mike Spencer, Cornell University. At universities, we have wonderful innovations often funded by DARPA or NSF. The transition of these innovations from research idea into a Series A funded company has often been called the valley of death, with the very, very low efficiencies. My question is, how can we significantly increase this efficiency?
Who would like to? Margaret.
Well, obviously this is quite relevant for me, and from a spin-out company from a university. There are few spin-out companies come out of universities that survive and become high-growth businesses. And what we really need is, at an early stage, we need good mentorship, good support from people that have done this before, and some input from some people that have led high-growth businesses to help us through the process of getting a business, forming a business. And I think that largely doesn't exist. And certainly for me, I'm having to find support. I've taken this business, I've spun it out from the university, but I now feel very much isolated on my own, and I have to find the people to help me to take that forward. And really, why does that not exist? And perhaps it's something that should be put in place across universities as a real support system of mentorship to allow us to get through this stage and grow high-growth businesses.
Let me give you a practical example. So if you go up to Cambridge, you can walk around the engineering department and there'll be engineers, and they do amazing things, and they smell a bit, some of them, and they're badly dressed because they're engineers and they love doing what they're doing. And then you can get invited to the Judge Institute, which is the Management Institute, and there will be lots of students that are impeccably dressed in a kind of very casual but perfect way. And they're all on the MBA course. And you'll go along and you'll talk to them, and they'll all come up to you telling you about their great new company they've founded. And with a few exceptions, the company's a crazy idea. Toothpasteyourdoor.com or something like that. And the simple answer to the question is, when you have something in the university, if it's technically based, you have people who are very good at technology and they live for it and they understand that, and they also believe that the world ought to work in an efficient model way. So because this product's better, everyone ought to come and buy it, and that's very straightforward. And by the way, marketing is cheating, because if the product's really that good, you shouldn't need the marketing. So you have that over there. And then you have people who are desperate to start companies and spend all their time studying the theory of marketing and launching products, but they don't actually have any ideas. So the one thing I keep trying to do is to get these two to get into the same room. And even then, they stand at different ends of the room. And so there's something about getting the different departments in a university to interact, because the MBA mob would love to have a real thing. And the engineers would love to be funded to carry on developing this marvellous thing while someone else does the marketing. And yet it's that transition that, unless you're very lucky, you don't have that duo of the technical person and the business person at that valley of death point. It can be very difficult to get through. So there's something there about moving cultures together of people that see themselves on slightly different paths.
Are they at opposite ends of the room because of the smell? If one of the great innovations could be personal hygiene, it might sort of bring the two together.
Andy wants to come in on this.
I think having access to information of all kinds is hugely important. So, for example, why should any particular technology be transferred and succeed if it's not a priori a given? So my point is, the help will come along by having information about the capital markets. What kind of money is available, early, middle stage? Can you go public in this, on this market? Whatever. What color of money is it? And what does it look like? What's the risk reward in this particular area? Is it more that you're competing with a large company, therefore you're dead, or is it you're alongside it, or is it something that will never be funded, it's got to have government support? All that sort of stuff. Also, what's your risk from on the university side, so to speak, from a promotion point of view? Because it is risk. Do understand what is precisely the criteria from your promotion in your university system tends to be publish, and that will be probably eroded. So I think access to information is key to this, and one of the very nice things that actually the Academy of Engineering is just doing now is forming, if you like, a business club, but it's third-party innovation, because if you go to your head of department like me, and you're within the university, I'll tend to give advice towards your promotion, how to be a professor in 3 easy steps, right? If you go to a vice-chancellor, they're caught up in their own system. So something that the Academy is, I'm very pleased the Academy of Engineering is doing, is to be kind of an external source of information or connection to people who can then give you advice, and then you can take the risk-reward as you see fit.
Thank you. I'd like to actually ask a question to link it to the education session yesterday. Regina, you mentioned that innovation can be understood. Is it true? Is there then a formula or model for successful innovation? And if there is this something that can be taught via formal education? And we've spoken already at the summit about engineering design and at what point do we bring that into educating the next generation? Is innovation something that can be encapsulated in that way?
Yeah, I actually observed themes in yesterday's education session which really resonated with me. This sense that the work needs to move more to a project-based discipline. And that, for me, if you think of innovation as a discipline, it's a doing discipline. And this intersection that I described, which is so characteristic, the hallmark really of the agency, is a project-focused orientation. And it drives towards this hot cauldron of activity, which is at the edges of science and engineering and a driving application. And we see this over and again. The deep analytics, the study of this intersection, the ability to identify it, is a teachable skill. It takes discipline to understand how to identify the opportunity and the gap that is created by an advance in science and engineering. And it takes the drive of the application to build, iterate, build again, test your hypothesis, and go. And that, I think, is part of what was being argued yesterday in the education panel. Yeah.
Thank you. Okay, let's have some more questions from the audience. Yes, so well, okay, so I'll come to you both, so one then the other, so you can share the microphone.
Hi, this is a question for Dr. Lynch. This is Halia Ebrahimi from the Daily Telegraph. Do you think that Autonomy's reputation has maligned UK tech companies, and will you be taking any legal action against HP?
Are you happy to take that question, Mike?
Yeah, of course. The situation, if we put this into a context of innovation, is Autonomy started as a company with 2 people, and with relatively little funding, it grew to become a FTSE 100, and then one of the largest UK software business. Now, as we know, Hewlett-Packard are disputing, the value that they paid for it over these things. Now, we haven't had any of the allegations, so it's very difficult to comment. We'd love to see them. We'd love them to put them in the public domain so that we could all pick over them. But it doesn't change the fact that Autonomy, and Hewlett-Packard wouldn't disagree with this, produced the world-leading technology in what is probably going to be one of the most important areas of computing, which is the handling of human-friendly information. On the subject of innovation, the very reason why that acquisition was done was because Autonomy was able to innovate in software in a way that Hewlett-Packard was not able to do at the time. And, Hewlett-Packard was a company built on innovation with Mr. Hewlett and Mr. Packard, and they produced an amazing company. And then what we've seen in the well-documented, past years is that they've had a great challenge, especially in the areas of software, to do that. And they haven't been able to hold on to the talent, which is the one thing we haven't really talked about in terms of innovation. It's all about the people. And, when they do acquisitions like ArcSight or Fortify or Autonomy and the people leave, that's the difficulty. Now, that's a company that, if it can get engineers back into senior management, it's a great icon. It should have a great future. It should be able to get back to innovating and move itself forward on that basis. And, I would hope that the fundamental technology that Autonomy brought to that in the hands of Hewlett-Packard will be something that changes the way in which we do computing. So, I'm still very hopeful. The other side of the equation is all the people that have left from Autonomy are all off doing amazing things. And, I see some of the companies they're working in, and, they've learnt a vast amount, and they're now doing incredible things out there in the UK, and we're going to see those companies coming along. So the legacy is an ongoing thing, and it will prove itself over time.
Thanks, Mike. Okay, I hope you'll be happy that will be the only Autonomy HP question I'd like to have in this session. So, yes.
Philippa Jeffress from the University of Birmingham. Professor Hopper, I've got a question about eating cake and the fact that we, perhaps in the developed world, are in the habit of continuously eating our cake even though we shouldn't be. And whether, because there are the delays in implementing the innovation, by the time that technology is actually out in the real world, the problem's already changed and we've eaten too much cake. Thank you.
Well, I'm not into flogging myself or ourselves. I find myself in the world I live in, and I think we do all right. But I can see an opportunity for the developing world. So let me let's just do a little bit of hallucination, okay? Here is how it might go. The platform is spreading, and everybody will have a mobile phone. It'll be quite powerful, really. And it's not too long from now. Many territories are getting covered in terms of the infrastructure, and the cost of the handset is going down, and then different business models are coming along, or have existed. So even the not the poorest, but the vast majority will have something that's got a very good camera, that's got a very good location system, that's got reasonable bandwidth to somewhere, and it's a fantastic sensor system. So not only will you be able to call your mum or dad and play games, which is also very important, but you have a tool which is a sensor system for the planet right there and then. So now imagine you can take a picture of a crop at this meter, that meter, and that meter. And you know which meter it is because it's precise and the resolution is there. And let me just give you one little technological twist. Say you can do a temperature photo as well as an image photo, or a bit of a temperature photo, not too fancy, but you've got the temperature. And so you could survey all the world's crops, right? Quite easily. You could have a system in the cloud which looks at these surveys, and perhaps a value-added service could be provided called Spot the Aphid, or here is what my virtual agronomy advice for you, anybody on the planet, is. If only a little bit of the effort that we put into games technology and image analysis technology were channeled in this direction, and it will be, I'm optimistic that they'll leverage those people out there who are tending their fields for, and their standard of living will go up. My naive way I hear that means family size will go down, and that's what I mean by having your cake and eating it. And I can see the path. I mean, it's, actually, I would argue I'm not being fanciful.
Thank you. Question over there.
Dale Carter, University of Strathclyde. My degree is electrical engineering, and I've been exposed to the energy industry throughout my course. So my question is, we're agreed that politics is a significant problem with regards to creating change. Therefore, do we have to innovate ourselves and be more involved with politics, or do we create systems and solutions to problems that politicians can't ignore, and therefore they have to change policy due to what we create?
Thank you. Mike, would you like to address that?
I think that you're raising what is a fundamental question for our time, and there's a quote from Edward O'Brien, which I think is, we have the emotions of the Paleolithic, we have the institutions of the medieval, and we have the technology of the gods. And what's happening is that in many areas of human existence, we can't change ourselves. We change on evolutionary timescales. So our loves and hopes and fears and desires and needs are not changing. However, our technology is changing the world around us at an amazing rate. You look at the financial system, multiple times GDP are traded in derivatives now around the world in milliseconds. There are feedback loops everywhere. All the engineers in the room know what happens when you put feedback loops randomly around systems. Well, they go unstable. And the old model was always that when the system started to go unstable, you did the financial equivalent of pulling the plug out of the wall because you could do it quick enough. Now it's going to happen too fast. It still takes the US banking regulator the same amount of time to cross Manhattan in a taxi cab. And as humans, the way in which you get things done is you put the bosses of the banks in the room and you stare at them. But the computers are now 10 times faster than they were even when the last crisis happened. What this is showing you is, Euro is another one. The need for France and Germany and the politics and the discussion and everything, it happens at a human timescale with a medieval institution. The technology is moving so much faster. So we have to change. And it's going to mean, for example, if you look at financial stability as an engineering problem, at the moment, no one will talk to anyone because we all have nation states. And we're worried that if London allows derivative positions to be known, somehow that will advantage Paris and all this kind of stuff. We have to change because the technology is not going away. The genie is, to use the cliche, well out of the bottle. And our medieval institutions have to move at least to, the sort of 1700s would be quite good.
Thank you. Andrew, did you want to come in?
One small point, I suppose, is I'd say, and I've worked in the policy world for many, many years now, and it's remarkable the resilience of the notion that change is a rational policy process. the merest encounter with political institutions and other institutions obviously tells you that's not the case. And I think our big problem is, from my point of view, is that whether you're looking at the financial markets or whether you're looking at our food chain or indeed whether you're looking at our energy systems, driven by certain powerful economic notions, we've ended up with a system which is characterized not by resilience but by vulnerability, and a system which I think was characterized by Andrew Haldane of the Bank of England and Bob May as one which is a shock propagator. The point at which it comes to politicians' attention and they feel they need to do something is obviously when those shocks propagate. And a wonderful example where you saw many things coming together was at the turn of the millennium, when you had the vulnerability of our fuel distribution system revealed by the road hauliers dispute. And you had the chief executive officers of our largest supermarkets in Whitehall telling civil servants and ministers that they had 3 days' worth of food left on the shelves, that we were in effect 9 meals from anarchy. And that partly was to do with the very centralised and vulnerable nature of the fuel system, but also the fact that, driven by the logic of a certain kind of efficiency and cost saving, notions of just-in-time delivery within the food chain, we ended up with a food system which was also actually not resilient to external shocks. And I think one of the great characteristics, one of the great challenges, is pushing the notion of greater resilience in all systems. And how you do that in the political context, I suppose, by reminding them that their jobs are at stake, and the increasing frequency and severity with which shocks seem to be occurring.
Thank you. Regina, come in.
Yeah, for a good portion of my career, I've worked at the intersection of technology and policy. And I think we need to be a little cautious to put so much blame there. I think that in my own experience, I have seen policymakers want desperately to do the right thing. And I have also seen technical people step away from their responsibility to communicate, to invest in the communication, to make it understandable, and to continue to have that conversation. And you can take whatever expectation you have about how hard that conversation is and how much work you have to do to prepare for it, and multiply by a factor of 10 or 100. And then you need to commit to the investment. And I will tell you that I have seen countless occasions where positions have shifted and where engineers and scientists have made it part of their personal mission to do that work. And it is part of our work. Yeah.
Thank you. Our next questioner is over the back there, yes.
Hi, Yingtao Liu. I work as a design engineer with ATAP. Innovation is one of the things that gets me excited about the work that I do. I work in the building services sector. But pretty much every day I have to deal with the fact that I have to design to industry standards that were written 20, 30 years ago. And the fact that ideas that go forth, in a way, are challenged by these industry standards that need a committee to come together and deliberate over, I don't know, a year or so to allow this idea to be included in engineering design is a bit of a deterrent. I wondered if there is any way, if anybody's got any thoughts on how we can be part of the conversation to get people in committees a bit more receptive to new ideas coming through an industry that is dealing with old standards.
Thank you. Dr. Li, I'll bring you in here. I'd like to know what the Chinese perspective is on industry standards, for instance.
I think I would like to share my own experience. In year 1996, at that time, the 3GPP, which is part of the ITU, started to make the 3G standard. So now everybody have the smartphone. You make the phone call actually through the UMTS about 15 years. At that time, we discussed which kind of air interface we should use, the physical technologies. And for the communication system, because of the requirement for interoperability, so they need to standardize that industry. But for some applications, for example, I have discussed with a doctor. He works in a major hospital, and that city is about 16 million people. They are now lacking of storage. Because of the medical image, if they can store, then they can trace back the people's the illness and can judge easily for the prescription. But now they are lacking for that. But we need not to set up any industry. That means, in that case, people need to provide a disruptive solution for them to store enough medical image. And the doctor requirement is very clear. So for those not necessary for the interoperability, maybe standardization is necessary. For some innovative application, maybe the fact standardization is a good solution. So from this point to this point, maybe there is some balance. And then standardization organization need to improve their efficiency. This is my premise. Thank you.
Thank you. Does anyone else want to comment on industry standards and how to deal with them if they're outmoded? Margaret, did you have anything on this?
I suppose for me, in looking at the drug discovery, tackling the FDA and some of the regulatory methods that exist just now is what I have to do with new technology, which is disruptive and we feel adds a lot more value to the current standards. To what my concern is the length of time it will take to engage with the FDA and challenge the way of thinking and the techniques that are there. So I'm looking to government to help me with that process, but certainly to me it does seem something that would take too long, and how can we improve that? I'm not entirely sure.
Thank you. Okay, we have about 15 minutes left, and plenty of questions already lined up, and I was trying to locate this. Next gentleman, next question there, yes.
Morning, my name is Jin Cheng Kang from Chinese Academy of Engineering. I like this panel because it is just talking at the intersection between engineering, innovation, and business activities. However, much has been talked about the current situation in industrialized countries. And little has been discussed about the emerging markets like India and China. And as is known, very dynamic and innovative activities are taking place in India and China. For instance, Tata and Huawei. Although in general, the innovative activities and experiences are still lacking behind, such as lack of regulations and standardizations. So my question here is whether the financial or capital experts and economic experts from industrialized world could help the Chinese and Indian business circles and engineering institutions to speed up the innovative activities, and also to let, through such an activity, to let the emerging market to be more widely known to the outside world. So I'd like to ask this question for answer from Mike Lynch and Dr. Andrew Sims. Thank you.
Thank you for pointing them out. Mike, first.
First of all, I think there is now very interesting innovation coming out of countries such as India, China, Turkey as well. Very young population doing fascinating things on the internet and that sort of area. So there are definitely very interesting new parts of the world for innovation. I think China's particularly interesting because the standard of the top universities in China is very high. And so what you're seeing is very good educational output which can be used to create innovation. In terms of what can governments do, I think some of it is around areas such as intellectual property protection. These days a global multinational can do its research pretty much anywhere, and many governments would offer it all sorts of incentives to go to their country. One of the things that such companies would look for is, for example, good defence of intellectual property. So showing a good track record of that, I think, could be very important. Making sure that you've got functioning things like capital markets for technology will also tend to drive the transfer of technology into businesses, because then the investors have an exit. But I'm actually very, very positive about those territories, because they kind of leapfrog a problem. So if you take India, where the mobile telephony is penetrating the population in a way that is very different to how it happened in the US and Europe, the legacy approach and thought processes are not there, and that's a big advantage. So the way in which people can think about using technologies when they're arriving new almost sort of leapfrog some of the thinking. So, for example, we see this process in the West where people are moving from, say, laptop to tablet. I still carry a laptop around, and there's very little rational reason for that, other than it's my background and it's what I'm used to and it's how I do things. And I think when you look at how mobile phones are used, particularly in India, you're starting to see usage approaches that are very different, and the thinking is different, and I think that's going to lead to actually really interesting innovation.
Thank you. Andrew? Well, it's such a big question. It's kind of quite hard to know where to begin, other than I find it's almost quite novel, living in the heart of the Anglo-Saxon economic model and with our recent history, to be asked for financial advice. I'm not sure if it's where I'd come for financial advice at the moment. And I'm involved in a thing called the Ashton Awards for Sustainable Energy, and they have an international award. And some of the projects that I've come across in many places in Asia and Latin America, you're seeing some very interesting innovations, for example, to support the rollout of micro, small and medium scale renewable energy technologies. You're seeing innovations in microcredit. There are innovations in business form around community interest companies, around certain forms of cooperative, which are supporting things happening at the community scale. There was a carbon commission in the London borough of Haringey, which took the London... For people who aren't familiar with it, Haringey is one of London's most divided communities. It was one of the communities where there was a lot of unrest in the summer just a couple of years ago. And they're charged with regenerating and rebuilding in an urban area marked by some wealth, but also some extreme poverty, and they've got many problems. And yet they've looked at innovative ways to support, if you like, Green New Deal enterprise zones and energy startups, innovative financial models there. There's a report called the Carbon Commission Report from Haringey. So there's a couple of examples there. I'm endlessly reminded, if anything, that how much we can learn in places like the United Kingdom from what's happened globally, whether it was indeed through innovations in microfinance and microcredit, or indeed whether it comes down to the Kenyan entrepreneur that we came across, who rather beautifully, in terms of the poetic unity of what he was doing, was taking the wheel axles of defunct sports utility vehicles and using them as a key component in making wind turbines. So I think one can look everywhere for insights. And I know China has got an immense challenge and opportunity, in that I sit here and I see being locked in China some of the most fossil fuel-intensive energy generation anywhere in the world. And at the same time, I see the renewable energy technologies, and especially the sort which work well at local level, going to scale faster and more impressively than anywhere else in the world. What I worry, where China's concerned, given the way in order to sustain its development is having to scour the world for more natural resources, is that we think that model is going to be the only model for the rest of the developing world. I think possibly the greatest challenge and the greatest innovation that we could demonstrate to enable China to develop and the rest of the developing world to continue to develop is to radically reduce our own ecological footprint to create the environmental space in which you might be able to do it.
Thank you. Our next question is up in the gallery.
Hello. Thanks for the panel for a very interesting discussion so far. My name is Ipshita. I'm from Cambridge University. And one thing that I wanted to highlight and ask a couple of questions on was the responsibility of the current generation of engineers and scientists coming through in terms of the number of patents that are lying in universities, and often researchers coming and going through to the system, but not enough innovation entrepreneurship stepping up from universities. I mean, just coming from Cambridge, I see my peers more focused towards perhaps taking up jobs in consultancies or banking or something of the sort, rather than becoming entrepreneurs. And I believe there's a difference between this culture, definitely between UK and US, because you'd find more tech entrepreneurs and more entrepreneurs who'd probably take their innovations and even drop out of university to take them through, whilst, at least from what I've seen here in UK, it's very focused towards just doing an education and perhaps looking at what's good for my career and going through and getting that consultancy job. So I'd like to open up to the panel on how do we get this balance of having tech entrepreneurs at an early age, as well as maintaining brilliant engineers, as well as motivating people to stick through to academia, because we're not really seeing a balance of that in the current generation.
Thank you. Yes, we'll have to keep it brief because I'm going to have to wrap up in a couple of minutes.
Very brief one. I mean, one thing from the UK perspective is, I mean, I'm saddened that UK has a financial system which seems to be almost uniquely bad at supporting enterprise, small and medium-sized enterprise. Our banking system is very different to the one you would find in the United States and the one that you would find in Germany, and Germany particularly, where you have a much more regionalized banking system. A lot of its governance is more mutual and cooperative, and where they have an explicit dual mandate, not just to make a profit, but actually to support business. And I think one of the great problems we have in the UK, actually, is that we don't have a financial industry which is geared towards supporting small and medium-sized enterprises. So we could learn something from the US and from Germany in that regard.
Thank you. First of all, I don't compare the UK to Silicon Valley, for example, in the sense that we should copy it. Silicon Valley is for Silicon Valley, UK is for UK, China, we all have our models and they're very, very strong. So this comparison sounds a little bit false to me. But I agree with you, there is a problem. There's a risk in starting a new venture, and people are rational beings, and if they get paid well in a city, good luck to them, actually. So a core point I sort of alluded to is that I think the system should be redimensioned so that many more things are launched and the recipient of the intellectual property and the goodwill thinks it's a bargain. And more things get traction as a result, because it is a risky thing and it's a rational human being. I might not do my academic career and might not make any money. Why should I do it? If you redimension it, and in particular universities change to going for volume out rather than picking winners, and be taken out of this difficult situation they're in, where at the margin they're having to make a bit of more money because they're not particularly well funded, I think that would help deal with the particular issue that you see correctly in some ways.
Thank you very much. Well, I'm afraid on that point we'll have to bring the discussion to a close, with apologies to at least 4 people that I've given the nod to, having anticipated they'd be able to ask a question, but we have run out of time. I know we could probably go on and eat completely into the lunch break with this discussion. It's been so fascinating. Please join me in thanking our panelists for a wonderful, stimulating session.